Okay, good. So no, there is no lag. I guess I was just like fixing a cable stuff. Okay. Okay, so let's start today's topic. Previously, you will see that the concept itself, in fact, we covered a little bit before during the past lectures, uh, the idea, like the terminology or understanding what is going on, that every variable, for example, has an address in memory. It has a location where it gets stored, and we differentiate between the address and the variable, but we never dealt with how to deal with addresses. So pointers are completely about that. One thing to understand is why pointers in C, right? Because as I said before, C gives you the fine-grained control over your hardware. So C is one of the lowest high-level programming languages, right? So we have assembly, which is very low level, and then we have the high programming languages, including C, Python, Java, C++, all other things. But those programming languages are not equivalent in their, I would say, proximity to the hardware, or they're being close to the assembly language. C is almost the lowest one in that, which means it gives you as a programmer more control of what is going on in the hardware, but this control comes at a cost, which is you have to, first of all, understand what is going on. Second is being able to deal with that. One of these low level hardware um, uh, like block or component that the C gives you a control of is the memory, right? I guess we said this before, but we will see in Java that Java handles the memory completely transparent to you behind the scene. It has its own garbage collector. You don't need to define memory. You don't need to destroy memory after you use it. This is not the case in C, right? We have seen this a little bit when we said that C doesn't have array boundary checking for you. So once you define an array size, in C, it allows you to go beyond your array limits, which most programming languages will not do for you. The reason for this, as we said, C doesn't prevent you from using the memory the way you would like to use it. But today we will see a little bit more detail of this reason. There is, I would say, a second level reason behind this, why C does not prevent you from accessing arrays beyond the limits. And it's mainly because of pointers, the way C deals with pointers. Good. So yeah, after this long introduction, let's go ahead and start. So we covered before that memory is organized as a sequence of bytes. It's called the byte addressable memory. And each byte has an address. So if we look into our memory like that, you see that you have different memory locations as if it's an array of single byte each. And each of this has an address, right? Something like this. And then the one has an address afterwards. So if this is 1, just give you an easy example, this would be 2. What I'm writing here is called hexadecimal representation. It's a way of writing integer numbers. I'm not sure if you already got to know hexadecimal representation or in your digital design course with Dr. Bruman, but it's a way of writing numbers. It's 1, 2, 3, 4, 5, 6, 7, right? Good. So these are called memory addresses. When you define a variable, you hold the value here. For example, if I'm defining an int of a that has a value of 10, the memory would hold the value of 10, right? But a itself is stored somewhere in the memory where you can point to by an address, right? So here you define by just saying int n, you declare a 4, because int is 32-bit, if you remember from our types lecture. So it's 4 bytes. So 4 bytes of memory are allocated to the variable n. And then afterwards, you set a value inside this memory location. So you store 10, you store data inside this memory address. We have seen this before when we passed a variable to the scanf function, and we said you need to pass the variable by address, where we called it passing by reference, such that the function is able to modify it. Now we will touch more about this, like we will cover in detail what we mean by this address operator. So for our A example we have seen, let's see, I have some visuals here. So assume I define something like int n equals 6. And this is something even that we can try together. So let me share a screen on laptop. I would like to do online GDB. Good. So assume I'm just defining a very, very easy variable like int n equal 10. If I want to print this 10, what we have done before is to say printf and then use the, so I would say in equal just to know what is this, and then use this specifier for n's and then print n, correct? This is supposed to give us n. Very simple, right? Oh, I should have just written 0 here, but okay. Good. So it just showed me n equal 10. To give you a sense of what is an address, let's say I want to print the address of this n. So what you can do here is say, and the address of n is equal. Now it would be this specifier, which is for an address, and then you would pass the address of n. This explains to you this address operator or the AND thing, right? So if you just run this, it gives you that n value is 10 while the address is some hexadecimal number, right? This b is the pointer because it just refers to pointer, which is the address where the variable is stored, and you need to pass the address, not n itself. So the difference between n and n itself here, which is the first parameter, is the value that is stored in this memory location, while and n is the address of this memory location. Good. So this kind of introduces us to pointers. I guess there is something on the chat here. Is 0x part of the hexadecimal? No, it's a way of writing hexadecimal Yan Hao. So 0x is saying that this number is represented in hexadecimal. It's no part of it. Okay, good. So what else? So this is what we printed as like the A and B. I'm just looking into the lectures here. If I go back on the tablet. So we said that B is the specifier that holds the address because it refers to pointer. And if we look into how the memory is stored here, this is an int of type, yeah, shared back, sorry. So you guys are able to see the slides now. So this n is an int, so it's a 4-byte. This is why you see 4 bytes in memory. If this is the start address, you see that everything afterwards start increasing by 1. C is 12, right? So D is 13, E is 14, and F is 15. So we have 4 bytes here. Every address is pointing to a single byte, and the value is 6 is stored here. Good. So AND is the address operator. Simply because it refers to a memory address, we said before that immediate values or constants, they don't have a memory storage because they are just immediate values. So it's logical to say you cannot use the address operator with them. So saying something like this will give you a syntax error because 1934 has no address in memory. It's an immediate value, right? Something to this as well. Y plus 5 is an expression that gets evaluated to a value, so it doesn't have an address in the memory, so you cannot use the address operator for. Good. So now we understand this. Let's go back and revisit dealing with arrays, right? So maybe I will go back to online GDB, and I would say assume now I define an array make sure I follow the slides. So assume now I define this P array of 3 and it holds, I don't know, any value, something like 1, 2, 3. Good. So previously I told you that the array itself, the array name is an address to the first element. And each element in the array has this index, B0, B1, B2. Here we don't have B3 because it only holds 3 values. So let's see this after understanding the address operator. See, if I want to say B0 equal this, and the address of B0 is equal that, right? So I would say is this, and then maybe I will do the same thing for 1 and 2. So if I do that, this should be B0 and B0. And then this should be B1. And this should be B2. Okay. So doing this, come on. Okay, so I guess again, online GDB is, I should use my Eclipse afterwards. Anyway. Don't you not need the address operator for arrays? I'm writing this example, Ian, exactly for that, right? So I will come into your point. I guess why it's compiled. Okay, let's see the theory and then look into the example, given that it's taking this too much time. There is no and for the B0, why? Here, right? So I guess you're referring to this. I will come, let me just copy that. And then do that. And then ask me to see, okay. Maybe, oh, it has a problem, I guess. That's bad. Okay, so let's go back to slides until online GDB is okay with us. So Ian question is a good start to what we want to discuss. So let's look into arrays in memory, and we discussed this before. So now I have these three elements, right? B0, B1, B2. And then this is holding -1 in this example, -2, -3. Good. So what is going on? If you print the value of B0, which is this first one, now I'm printing only the locations, but if you print the value, you get the value that is stored. That's normal, right? And in this case, as Ian is saying, I don't need the address thing. But if you want to print the address of the first location, then you need the AND operator. Why? Because B0 itself is not an address. It's a normal variable, right? It's an int variable, because if you define an array of ints, every single entry is an int. So this is an int variable, which means to print its address, you need the AND. What confused Ian is what we said before. For the array name itself is an address to the first element. So if you want to print, if you would try something like this, the memory location of B0 has address, and then you do this pointer here. If you only send B, which is the array name without any index, now you are referring to the array as a whole, not to a single element, and you would find exactly the same address of B0. Just to double check what I told you before, is that the array name is the address of the first element, which is a pointer. You will find that B and B0 are equivalent. If we had online GDB working, I would have tried this with you, right? Is there any question here? Did this answer your question, Ian? Why there is no and for the first B0? We have it. Yan how? That's the value of B0. Okay. Again, another online compiler. There are so many, but yeah. Okay. Karina, yes. B equals the address of the first element and B0. That's correct. But you cannot. We'll see now in more details, but generally what you said is correct. Michael, this one even has time steps and stuff. Good for debugging. And oh, thanks. Good thing. So we will try another compiler afterwards in other lectures. Good. So yeah, so if we try something like this, what you will see, something also I wanted to show you is we said before that arrays are contiguous in memory. They are back to back, so they have high locality. Elements are subsequent to each other. What is the proof of this? The proof, if you define an array like this with 3 elements, you print their addresses, you will find that they increase by 4, right? Why do they increase by 4 here? Any idea? I mean, if they are adjacent, they would have +1, right? Yes, Mark, because each entry is an int. So B0 is an int, and every int takes 4 bytes. So you take the 4 bytes for the first one, and then 4 bytes for the second, 4 bytes for the third, but they are back to back, right? Good. So visually, it's like something like this. These are 3 elements. The first one is 4 bytes. The second one is 4 bytes. So 1, 2, 3, 4, and that's B0. 1, 2, 3, 4, that's B1, and the same thing for B2. Everyone is holding 4 bytes. This is 0, 0, 0, 4, 0, 8. And that's very important to understand because pointers are mainly about doing arithmetic operations in these addresses, right? Okay, good. So this is what we were saying. What does the name of an array represent? In C, the name of the array is the address of the array, or in other words, the address of its first element, right? To be very precise, but this is something of an advanced thing. It's not completely equivalent to that. Like, I mean, yes, it holds the value of the first element, but C differentiates between the array name itself and the address of B0, right? So there are some operations that you can do in B0 that you cannot do in the array name, but take it as a general rule. If you try to see an online GDB, I'm not sure if it's working now, but let me see. Okay, you know what? Maybe I can try the one that you guys posted on the chat and see. Okay, let me try this and see. Then visualize execution. Okay, it has some good visualizations, but where is the output? Okay, I should look into this later. I don't want to waste time, but oh, because you debug, you move line by line. Okay, I don't want to move line by line. Is there a way to just run? Okay, maybe I just do this later. So going back to slides. So if I look into the array name, and if I try to do something like this, the address of B0 is and B0, similar to what we have done in the previous example. But now add a line that I would do Eclipse, Salah, but maybe next lecture, it takes time to open as well. And you need to define a project and declare a project, and it takes time. Good. So the address of the array is, and now we are only using the array name. If you do this and you try it, it would give you exactly the same address, right? Which is kind of something you can check yourself. Something that is good about programming is anything we would say, you can try, right? If you're not sure about a certain rule, just try it out and see what the compiler would give you, right? How does C access elements of an array? This is a little bit more detail about understanding that the array name is an address of the first element. Now, let's discuss how the compiler is accessing elements one by one. Simply what happens is, if I'm trying to access B3 and I have this array that holds the values 3, 4, 0, 0, and B0, 1, 2, 3, this is B3. By just doing this, what the compiler is doing, it's taking B address, the array name, add to it 3 entries. So you're telling the compiler, I want to access the data that is stored in the third location of that array. Third location is defined at 3 multiplied by the entry size. So assume that the address is 0, 0 for simplicity right now. What we discussed before is that because this is int, so the second address is 04, 08, and then 12, correct? Which is, yeah, which is 0C. Right? I don't want to confuse you, but that's 12, right? So I want to access B3, which is in this 12 thing. How does C knows that this is at address 12? It knows that what is the address of the first element, which is the array name. It knows that this is array of int, so the entry size is, what is the entry size in this case? Can you help me with that? 4, exactly, because it's array of ints with 4 bytes, 4. So it goes to B plus 12. If B is 0, 0 in this case, it goes directly to address 12, which is C0. So you see how the C knows from B3 index what address it needs to access in the memory, right? It just does some pointer arithmetic on the array name, and this takes the compiler or the hardware to the memory location where you hold your third element. Good? Is there any question here? That's very important to understand, right? This is a concept that many of the programming problems you might face is because of not understanding this very well. So if you have questions, please ask, right? Okay, good. So a consequence of this is what we said before, which is C allows you to go beyond your array limits. Why? Because as we have seen right now, C doesn't even differentiate what is an array and what is part of the array and what is not. It just takes the array address, take the index you have added, do a pointer arithmetic, and goes to this memory location. Whether this memory location is within the array or not, it doesn't really matter. For example, if I did something like B -1, what would happen is C would do exactly the same thing. Take B, which is originally was our 0, 0, take the index, but now I don't want to have this as 0, 0 because it will give you a negative number. Let's say B was starting from something like, I don't know, 4. Good. And then this is the index, multiply this by the entry size, which we said is 4. That means now the address you want to go to is 0x4 -4, which is 0x00. Going into the memory, if B is starting at 0x04, you can simply see that 0, 0 is not part of the array. It's the element directly before the array, right? C doesn't matter, right? Or this doesn't matter for C, or C doesn't care, right? It just goes to a certain address that you pointed to. You have to be careful about not going beyond your array limits. But now this gives you a further understanding of why C is not doing this boundary checking for you, because everything is done as a pointer arithmetic. Good. Okay, good. We said this before, please pay attention, don't go to your array boundaries. This can cause your program to crash, or even your operating system to crash. Now, we keep saying pointers, pointer arithmetic. What are pointers, right? Pointer in C is nothing other than a new data type, right? So it's a data type similar to int, similar to double. If you remember when we discussed the lecture of the data types, we said what defines a data type? What a data type does for us? It does for us multiple things. Can someone remind me what, by just saying int x, for example, what does it mean? What int is giving us? Any hint? Allocate memory, correct, but not just allocate memory, allocates a certain size of memory. So the data type is telling you memory size, Nico, that's correct. So int, for example, is 4 bytes. This is one thing, so it tells us the number of bytes or the memory location around, that's correct, the memory size, one thing. The second thing is the type of operations that can be done on this variable, right? So the operations that are done in int are different than the operations that are done in double, that are different than the operations that are done in character, right? So also the type of operations that can be done, the values that this variable can take. Int is said like 32 bits, which means you have certain values. Double can take floating point values, but int cannot. So also what type of values that the variable can take, right? So a data type gives us the set of values, the operations, and the storage or representation in the memory, right? So what about pointer? How pointer is a data type in that sense? The value of the pointer variable is a memory address. So it tells you what kind of variable, what kind of values that it can hold. The second thing is you have different pointer types, because a pointer, if it's a memory address, the memory address can hold an int, or it can hold a double, or it can hold a certain value, right? So what's special about pointers as data types is they can hold different types, or they can refer to different types, right? So for example, here I'm defining a pointer of an int. which means this address can hold a variable of type int of 4 bytes, right? This is a pointer of double, right? So we see that this asterisk means you are defining a pointer, right? You can also have a pointer of character or a pointer of any variable, right? So two things we said so far, just to make it easy. Pointers are just memory addresses. Those memory addresses can refer to different data types. It can refer to an int, can refer to a double, character, or anything, right? How to declare a pointer? You just simply say, okay, I want to define a pointer to an int, so it's an int asterisk and the name of the pointer, right? This or this doesn't matter because sometimes this confuses people. Where you put the asterisk after the data type itself, which is the int, or the name of the pointer, it doesn't really matter. Here I'm defining a pointer that points to a character variable. Let's see what happens in memory. So I defined a pointer of type int. So that means in memory, this, remember, the pointer is nothing other than a variable, right? So it gets allocated in memory. So I declare this in memory. So I define a variable called int pointer, and then it holds some value. So far, I didn't assign or initialize int pointer by anything. That means the value is still empty, right? But because int pointer is a variable on its own, it has to be stored in memory. It also has an address, right? And this is one thing that people get confused about pointers. If you understand that pointers are variables and they have to be stored in memory as well, so they also have to have an address that is pointing to them, right? So if this is my memory, this is a memory location. This memory location itself holds an address, right? So it's what is inside this. It depends on the type of the variable. If in case of a pointer, it's still an address, but it has an address that is referring to this memory location, right? Good. So far we didn't initialize this. Now I defined another int variable called n, and it has 8. It has a certain address in memory, and now it has a value. Because we said int pointer can point to another int variable, what I can do right now is to say assign int pointer the address of n, right? Using the AND operator. By doing this, what would happen in memory is that you are taking the address of the variable n, which is 0x24cb04, and put its value in the variable n pointer, right? In another graphical representation, what does it mean? Is that n pointer value is pointing to, this is why it's called the pointer, it's pointing to another variable that is integer and has a value of 8. Do you get confused? Is there any question?
So when does this stop? If everything has a pointer, aren't
Yeah.
there infinite pointers for
Perfect.
everything?
Yeah, we will see this. That's an excellent question. So we will see later in I guess in coming lecture or the lecture afterwards, based on our progress, is that pointers can have pointers that are pointing into it, and we have a chain of pointers. So it doesn't end, in fact. So the capability doesn't end, but your usage will depend on what you need. If you need only a pointer to a variable, then you will use one level of pointers. But if you need pointers to pointers, for example, a 2D array, we will see this in coming lecture, then you have a pointer to a pointer. But the general idea is a pointer is an address to a variable, but the address itself is a variable that has to be stored in memory, and it holds a variable it has to have an address on its own, which can be pointed to by another pointer, right? So this is called pointer chaining, right? But people usually doesn't go beyond two like pointers to pointers. Like people, for example, don't do pointers to pointers to pointers because it doesn't have practical use cases, and also it's confusing, right? Good. Is there any other question? Question, Aaron. Can we store data more than 4 bit in the int pointer, or is it going to cause overflow? I guess what you meant, Aaron, is 4 bytes because int is 4 bytes, and it will not store it. So the thing is, the pointer, as you can see here, it refers to this 4 bytes. It only holds the address, so it doesn't store, the pointer doesn't store the value of the n. It holds its address, right? If you try, I guess what you're saying, for example, if you try to declare an end pointer like that, assume I already defined my end pointer like this, and I defined a double variable, x. And then if you say something like n pointer equal and x, if this is what you are saying, this will give you an error because now it violates the pointer type, right? So this can't happen.
I have a question.
Go ahead, Arjun.
Is there an advantage to using, like say for example, because we know that anything in integer can be stored in double, right? Is there an advantage to use an integer pointer, or could you just use double pointer for every number?
Sure. If you use double pointer for every number, that means all your variables have to be double, right? So what I mean is, I guess what you said is the other way around. Can a double pointer point to an int? No, it cannot as well, right? So for example, if you have a double pointer like this, let's call it double pointer, and then you have a double variable x, you have an int x, like let's say it's int n, and then say d pointer equal and n, this also will give you an error. So the type has to match. There is no casting in pointers, right? It has to have exactly the same type that the pointer is declared to. So a double pointer has to point to a double variable. It cannot point to an int variable, right? So if you define all your pointers as double, then all your variables will be double, but then you are wasting too much memory because most of the time maybe you're dealing with ints. So instead of taking 4 bytes, you are taking either 8 bytes or 16 bytes, right? Michael, why do you ever want to use a pointer at all? We will see practical examples, Michael. So they are very, very useful, in fact. Question, what if we don't initialize n to 8? Would it still return the address? Yes, that's an excellent question, Singida. So assume I didn't initialize n, so I didn't have this, this equal 8 here. That means n doesn't have a value, right? Because n pointer, so once you declare a variable, even if it doesn't have a value, it would be allocated in memory. Remember, if we don't do initialization, it would hold some garbage value here. But this doesn't prevent n pointer to point to the address because all what it matters to the n pointer is the address itself. The value is not what the pointer is caring about, right? Good. So to summarize, any variable has two things. A normal variable, I'm not talking about pointers here. A normal variable has two things, a value and an address. Pointers are concerned with these addresses. The values themselves are the concern of the variable, like of the n. For example, n is holding the value, which is 8, or if not initialized, it's a garbage, while n pointer will be holding the address itself. So whether you initialize it or not, pointers don't care. Good. So what is this? So here we said, okay, this is called the address operator, and it assigns the address of a variable to a pointer. There is the other way around. Assume I want to access n, but through the pointer, because we said the pointer is referring to this variable, right? So is it possible to modify the value in this memory location by using the pointer? Yes, it's possible. So what we would do, if you do something like this is called indirection or dereferencing, which means you are telling the compiler, take the n pointer, take the address that it's referring to, go to its value and assign it to be 20. So to read it simply, here you would say this is the address of n, which is the address operator, while the asterisk is the value. So you would say here, take the value that n pointer is pointing to and change it to 20. So asterisk is the value of, and is the address of, right? So they are the opposite side. Okay? So if you do this, what would happen in reality is you would change n value from 8 to 20. Good? By doing this. In other words, doing this is completely equivalent to say n equals 20, right? So this is n, right? If I write it in other words, I would say n and n pointer are the same, and n and n pointer are the same. This is the rule here. Is that clear? Question: what if we wanted to print n using n pointer, but n doesn't have a value? What would be printed? Again, the uninitialized value inside it, like the garbage value. So the general rule was that if you didn't initialize a variable, it would hold anything, 0 or something else, right? So it would hold whatever value it contains. Good. How much memory does a pointer use? That's also an excellent question, Victor. So a pointer is usually, because it's a memory address, so it depends on the width of your memory address. This is usually either 32 bits or 64 bits, right? So it's a 4-byte or 8-byte. Depends on, it's implementation dependent. But your question, in other words, is what is the width of my memory address, right? Up to 4 or 5 years ago, most of machines were only 32-bit machines. That's why like the pointer would be 4-byte. But now, almost all of our modern laptops are 64 bits. That means our pointers are 8 bytes. So it's implementation dependent, right? If you use a very simple microcontroller that only has a very small memory, this might be even a single byte, right? Good. Excellent. So if you try to print this, you are also printing n value, which is 20, right? It's the time to make sure we are, okay, good. This is called, this asterisk thing, as I told you, it can be read as the value of, it's called indirection or pointer dereferencing. And again, you can use n, like asterisk n pointer, exactly as you are using n, right? So an example here is, if you are declaring a pointer of int, this is how you declare an int pointer. Now I'm initializing it to null, which means it holds no address at all. It has a null value. I'm declaring 2 different variables, a and b. And now I'm assigning the address of b to b pointer. Good. That means now b pointer is pointing to b, which means the value that b pointer is pointing to is what? Can someone say? What would be the value of that? B, which is holding 25. Yes. So A would be 25. And then if you do this, then B would be 0, right? So if we go through this line by line, let's see what is going on. So initially, I'm defining the B pointer. It gets null, so it has zeros here. I'm defining A, but I didn't initialize it, so it has no value. I'm defining B, and I'm assigning it the value of 25. This is the initialization in line 1 and 2. Then in line 3, I'm saying, please take the address of B and assign it to the B pointer. So if you look into the address of B, that one, it gets assigned to the pointer, right? And then in line 4, I'm saying, take the value that B pointer is pointing to, which is here 25, and then assign it to A. So you'll find that A gets 25. And then finally in line 5, I'd say, take the value that B pointer is pointing to and make it 0, so it's 0. I guess this example kind of clarifies how things work, right? Is there any question in the example? Okay, good. So now from the examples, let's look into the general rule. What the pointer as a variable, what it can hold. We have seen that it can hold the address of a variable, right? We said in pointer equal and A or and B or and N, right? It can also have a null pointer, which means I'm pointing to nothing at all here, which means it's still not defined. You can also assign a pointer to a pointer, right? So you can define 2 pointers of the same type and assign one to the other, right? One example would be I'm initializing 2 end pointers, both to null, and then I'm defining an end variable of n. And then what would happen in memory is you would have these 3 variables, right? End pointer 1, end pointer 2, and n. Now, if I say end pointer 1 equals the address of n, someone asked what would happen if I didn't initialize n. This is the example is showing that, right? So what you would see is that now in pointer 1 is pointing to n. So it holds the address of n. So if this address was 0xf9, you would have here 0xf9, right? Then to see the second, like the third thing here, which you can assign a pointer to a pointer, I'm saying in pointer 2 equal in pointer 1. Can you imagine what might happen? In pointer is nothing other than a variable. So you take the value that this variable is holding, you put it here. So it's 0xf9, which graphically means in pointer 2 would also be pointing to n, right? So now you have two pointers pointing to the same variable. Is that possible? Sure, nothing can prevent this because pointing to means holding the address of. The address of a variable can be held by hundreds of pointers. There's no problem here, right? Good. Okay, good. This is what we have been doing. Assume now I'm saying assign the value of n pointer 2 to 76. That means now n should get 76, right? Now I can do dereferencing to the other pointer by saying increase the value of n pointer 1. This should be 77 now. What does this give us? It gives us that if you have two pointers pointing to the same memory location of the same variable, doing dereferencing or operations on any of the pointers would reflect on the variable, right? Because as you can see from the graphical representation, both are pointing to the same place. So any change using dereferencing of any of them would reflect on the variable itself. Is there a question? Okay, good. Okay, so we have seen so far pointers of type int, but same rule applies to pointers of type double. What I'm doing here, I'm defining two pointers of type double, and I'm making them null. You can either do null or zero, both is the same. So why a null pointer cannot be dereferenced? This can be logical from what we said so far. Can someone kind of think why this might happen? Why a null pointer cannot be dereferenced? What is even dereferenced mean?
You're basically trying to get the address that's stored in the pointer, but if it's null, then it means there's nothing stored in the pointer.
Exactly. Yeah, because as also others said in the chat, dereferencing means, as we said, take the value that this pointer is pointing to, but null means it's pointing to nothing. That means this operation is not allowed, right? Good. So now dealing with pointers and functions, things start getting messy and interesting, right? But not too much. We have seen this before in other words, right? Remember when we said you can pass a variable by, we did this in scanf, we needed to pass the address of the variable to be able to modify it, right? So the address of this variable is nothing other than a pointer, right? So we said by default, arguments are passed up to a function by value. But if I'm passing a pointer to a function, yes, the pointer itself is passed by a value, but the pointer is pointing to a variable, and passing the address of this variable means passing this variable by reference, right? So what does it mean? Let's look to an example to see what we mean by this. All of this we discussed before is theory, so I guess examples are better to explain. So assume I define two variables called a and b in the main, holds the value of 100 and 200. Now, assume I have a function called swap, and then swap takes two addresses, which means takes two pointers, and then passing the address of a and b to this. Let's look into the implementation of swap. Swap is just taking here two input pointers. Both pointers are of type int, which means they point to ends, right? That means x pointer and y pointer are the input parameters to this function. By calling swap in the main, I am passing the address of a to x pointer and the address of b to y pointer. So here x pointer would be pointing to a, y pointer would be pointing to b. And then doing the swap operation, what would happen is, let's look into all of this, is just explaining what's going on. Doing the swap operation by using the temp variable, I define a temp, I change their values. Values here means the dereferencing operator. So I say take the value that y pointer is pointing to, assign it to temp, which means temp here would hold the value of. What would be the value on line 2 for temp? 200, perfect. Then make y pointer equal x pointer, which is 100. And then assign the x pointer, y pointer, which is 200. By doing this line by line, what I'm doing, I'm saying in line 2, take the value that one pointer is pointing to, which is this 200, assign it to the 10, then 100, and then swap this. So it will end up having a and b changed even in the main function or in the caller, right? Right? So after the swap, the main idea is now a and b themselves are changed. Why? Because you pass their address, not their value. In other words, you pass them by reference, right? Why is there an asterisk in the end x pointer? Because it's, Nicole, this is how you define a pointer, right? So you have to have the asterisk to say I'm defining a pointer here. This is a pointer to an end variable, right? We said this is how we declare it. Is this the only way of passing a value by reference in C? No. Sorry, go ahead. Go ahead, Nico. Oh, I don't hear you.
You're declaring those in the header of swap?
Okay, that's a good question. I'm passing them. So I'm saying that these are the input parameters for the swap, which means I'm saying this swap function is expecting 2 pointers of type int, right? So any value that would hold an address to an int is valid to pass to swap, right? Is that clear?
The star makes it so that you can only input an address.
An address, exactly, yeah, a pointer. Because if you didn't have this, assume we removed it, right?
Yeah.
What would swap expect? It would be expecting an int value, right?
Mm-hmm.
So doing this will be wrong because and a is not an int value, and a is an address value, right?
Okay.
Good, thanks.
Yeah.
So what we have done before was also passing by reference, but in a different way. We didn't use pointers, right? If I want to write the swap function without using pointers, what I would do, I would say void swap int and x pointer. It shouldn't be pointer now. I would call it anything. Let's say x, and then int and y, and then I'm not sending here and. This is also another way of doing pass by reference in C. So you either specify you are expecting the address of a variable or passing it by reference, or using pointers. And to be honest, using pointers is more professional, right? But I just wanted to make sure you guys understand what we have done before. Remember, this thing is completely equivalent to what we tried before of scanf, and then doing something like, I don't know, d, and then variable num, right? So here you are passing again the address. Why? Because if you look into the implementation of scanf in the header file of studio.h, you will find that scanf is expecting a pointer to whatever type you define, right? Good. What's the advantage of using pointers in this case over to what you did before? There is no advantage from the functionality point of view. It's just a more professional code. If you are dealing with addresses in C, it's better to be precise and use pointers for this, because pointers were made mainly to do addresses, right? Good. Now, I guess this is something also that we said before. If I want to return, okay, what is the limitation first? The limitation is that functions in C only return a single value, right? What if I want to return multiple values? We said you will pass them by input, right? And then pass them by reference, right? So for example, if I want to write a function that returns both the sum and the def of 2 inputs, I cannot do this simply by returning a sum and a def in the same time, right? What I would do instead is I would say I define a function that takes 4 parameters. The first one is the value of x and y that are the inputs, and then address of the sum, because this is the one that I want to modify, and the address of the def, right? So I will pass 2 things by value, and whatever I want to return, I can pass by reference. And we said before, passing a variable by reference means you allow the function to modify it. So as if you are returning it as an output from this function. You will see in lab 2 that we do this heavily. So almost most of the functions in lab 2 have a return type of void. So it means it returns nothing. Does it mean it doesn't have any change on the output? No, but we deal with all the outputs as if they are input parameters to the function itself, right? So by doing this, to call the function, I can pass x and y as a value and then send the address of sum and def. If I define, okay, all of this is just, yeah. So to define the or prototype the function itself, I need 4 different things. The first 2 are the inputs. So these are enough to be ends because I'm just passing their value. But the second 2 has to be pointers to end because I want to change them, right? I won't be able to send an address here. And to send an address, this has to be a pointer. Is that clear? Good. So if the time is not over and online GDP time is already over, okay. So I was going to try this with you, but simply what we are doing is what we are doing here is say, okay, use the value of some pointer to hold the sum and use the value, so dereferencing, pointer dereferencing, use the value that pointer is pointing to hold the subtractor operation. So what happens in reality is that in the main, you would have these 4 things. You have x, y, and sum and def. And here you would have a, b, sum pointer and def pointer. The way this works is that this 100 is passed here as a value. So a and x are different memory locations, and y and b are also like passing only the value, but here some pointer is directly pointing here and difference pointer is directly pointing here. So if you do this, changes in a and b are not reflecting in x and y. Here, for example, inside the sum def, if I said a is equals 1000, after here, it doesn't make any difference in x in the main function, right? But any change in the value that some pointer is pointing to, which is this one, at the end of this line, this sum will hold the value of 300. While after the difference, this would hold the value of 100. Good? Or in this case, it should be, sorry, it's not 100, it should be negative 100. Good. Okay, let me take, so okay, given that we're over time, I will stop here and take few questions before we leave. Thanks everyone. So why is there is only call this was your Sarah question? What's the advantage of using pointer? I guess I already answered this. Erin, can you use multiplication and indirection? How does this work when there are the same symbol? Okay, perfect. That's a good question, Erin. So multiplication is an operation, right? So it's called operators in C. So operator is expecting a variable before and a variable after. First operand and second operand, right? So the syntax itself, like the context of the thing that you are using the symbol in will tell the compiler what you really mean by this. The same question applies for if you are using AND as an address or AND as a unary operator that is doing AND operation, right? So both also as like do the same thing, but they have different meaning. How the compiler would know what you mean based on the context. Yeah, Goten was already explaining this. Perfect. Thanks. Okay, so thanks, guys. I'll do my best to make sure I post this this lecture by today because that's a very important topic. And please make sure you don't leave it for the next lecture because the next lecture is going to build on top of that. Nicole, what does unary mean? Means it takes a single operand, right? So for example, here defining this took only a single value afterwards. While if you do a multiplication, it would take one before and one after, right? Good. Thanks everyone and have a great weekend then. Bye-bye.